Wabarakatuh. The Honorable to Miss Yumi S. Industrial Statistic Lecturer of Industrial Engineering, Andalas University, and welcome to everybody who are watching this video. Here, we from group that consists of 2 people, me, Fathurrahman, Ananda, Menaz, with number student 18109333017, and my another friend Shafhan that would introduce himself later. And here we are going to talk about simple linear regression and correlation. So first, let's move to the next slide. We are going to talk about the introduction to simple linear regression. So basically in statistics, simple linear regression is a linear regression model with a single explanatory variable. That means that is concerned with 2-dimensional sample points with one independent variable and one dependent variable. Conventionally, the x and y coordinate in a Cartesian coordinate system, and finds a linear function that as accurately as possible. Predicts the dependent variable values as a function of the independent variable. So here we can see in the slide that the case of simple linear regression consider a single regression variable of or predictor variable x and a dependent or response variable y. Suppose that the true relationship between y and x is a straight line and that the observation y at each level of x is a random variable. As noted previously, the expected value of y for each value of x is this. This is the formula of value of y for each value of x, where the intercept and the slope are unknown regression coefficient. We assume that each observation y can be described by the model of this formula, this model, to each observation y. And yeah, that's the two formula that we are going to use to expected value of y for each value of x, and for observation y that described by this model. So the next one is about the method of least square or Walpole. That the definition is the least square method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of the offset of residual of point from the plotted curve. So it is the statistical procedure to minimize the sum by minimizing the sum of the plotted curve. Least square regression is used usually to predict the behavior of dependent variable that we have mentioned before. They are dependent variable and independent variable. So here in residual sum of square is often called the sum of square of the error about the regression line and is denoted by SSE. This minimization procedure for estimating the parameter is called the method of least square. Hence, we shall find A and B so as to minimize it. So this is the formula to finding the method of least square or Walpole. So next we are going to talk the properties of the least square. So the least square estimators of the intercept and slope, we have to assume the model that we have seen before, the y, the intercept and slope in slide 2. We can assume that the error term is a random variable, is still a random variable, but with mean 0 and variance square. So the values of the slope and intercept depend on the observed y. Thus, the least square estimator of the regression coefficient may be viewed as a random variable. We now investigate the bias and the variance properties of the least square estimator's intercept and slope. So next we are going to talk about the estimator of variance. So here we are also estimate the variance by using the residuals. That there is actually a known parameter in our regression, that is the variance. And how we going to achieve it? We are using the formula of the residual here in the EI, and the sum of square of residual, often called the error sum of square, or SSE, that we have mentioned in the beginning of this presentation. Next presentation will be presented by my
me. Alright guys, I'd like to continue what Fathurrahman and Menaz what presented before. But first, let me introduce myself. My name is Shafhan. My student ID is 1810 93 30 and 32. Now, let's be next to the slide. The slide. The coefficient of the correlation and determination in ontogeometry book. From the text, we assume that the joint distribution of xi and yi is the different normal distribution, and nu y and variance y are the mean and the variance of y. Nu x, variance x are the mean of the variance of x, and the p is the correlation coefficient between y and x. Recall the correlation coefficient is defined as this formula. P is equal variance xy divided to variance x times variance y, where variance xy is the covariance between y and x. And this is the formula for the coefficient correlation and determination. Alright. From this text, we can conclude that the P is the correlation, and nu y and variance y are the mean and the variance of y, and the nu x variance x are the mean and variance of x. Let's proceed to the next slide. This next slide is the estimator of P, is the sample correlation coefficient. This formula is P hat is equal sigma y in parenthesis xi minus x bar divide square parenthesis square bracket sigma and open parenthesis x minus x bar close parenthesis to the power 2 times sigma open parenthesis y minus y bar close parenthesis to the power 2 and to the power half. This will be same the value with the sxy divide to sxx times sst to the power of half. So this is the example if you wanna know. This value of the sxx and this is the value of sst. Let's see to the next slide. Next slide is using the model for estimation and prediction in the books of Walpole. The equation y is equal to b null plus b1 times x may be used to predict or estimate the mean response in y to x null at x equal x null. We shall use the point estimator y null is equal b null plus b1 times x null to estimate new y to x null is equal b null plus b1 times x. It can be shown that the sampling distribution of y null is the normal with mean. This is the formula. So this is the prediction is will be same with the value of this is action because for we know the value of the action, the formula is like this: y is equal b null plus b1 times x. So let's go to the next slide. This is the prediction interval. So this is we prediction the interval of the linear regression. The formula is like this: new y hat null minus y null is equal a times y null hat minus y null is equal to or same with a square bucket b null plus b1 times x null minus in the bucket b null plus b1 x null plus e null is equal to 0, and the variance is variance quadrat y hat null minus y null is equal to variance quadrat b null plus b1 x null times x null minus e null is equal to variance quadrat a hat plus b1 in bucket x null minus x bar plus bucket minus e null. So it will be same. The formula of the variance is the variance quadrat square bucket 1 plus 1 over n plus x null minus x bar 2 power 2 over sxx. And this is the formula for t, which has a t distribution and -2 for degrees of freedom. So that's all, friend. Thank you. You've been watching the presentation, and thank you for chapter 2. We already explained the presentation before, and that's all. Assalamualaikum warahmatullahi wabarakatuh. See you.